Today's video will help you review the procedures for writing net ionic equations, calculating with concentrations, and the rules for significant digits. When writing net ionic equations, the very first step is to write a balanced equation. Once that is finished, use the solubility table in your data booklet to determine which of the ionic entities will dissociate. Rewrite the equation with all soluble ionic compounds separated into their ions and the acids ionized. Any entities that are the same on both sides of the equation should be cancelled out. Your final step will be to rewrite the equation to show the net ionic equation. Here is an example with barium chloride and sodium sulfate. In step 1, the double replacement reaction is predicted. For step number 2, a quick check of the solubility table showed me that barium sulfate is the only entity that won't dissociate. In step 3, I canceled out anything that was the same on the reactant and product sides, which was the chloride and sodium ions. Step 4 shows the net ionic equation. The next topic we will be reviewing is concentration. The two formulas that you will need to use and remember are the equation that is used to calculate moles from mass and molar mass, and the equation that uses moles and volume to calculate the concentration. In this question, you are asked to figure out how much silver nitrate is required to make a solution with a specific volume and concentration. Since you are given the volume and the concentration, you should be able to calculate the number of moles required. You will need to know the molar mass of silver nitrate so that you can use the number of moles to determine the mass required. Remember that when you are figuring out the molar mass, you need to add up the molar mass of each element in the chemical formula. In this case, there is 1 silver atom, 1 nitrogen atom, and 3 oxygen atoms. Adding the individual molar masses will give you the overall molar mass. Now you can multiply the number of moles by the molar mass to determine the mass of silver nitrate required. When ionic compounds dissolve in water, the concentration of different ions may not be the same. The concentrations will depend on the mole ratios. If you need to solve for the concentration of ions, the first step must be to write a balanced equation so that you will know the correct mole ratio. When calculating the concentration of aluminum and sulfate ions in aluminum sulfate, the first step is to write a balanced chemical equation. From this, you will see that there are 2 aluminum ions for every aluminum sulfate added to the solution. This means that the concentration of aluminum should be twice as much. Another way to figure this out would be to use a mole ratio of unknown over known. The coefficient in front of aluminum, the unknown, is 2, and the coefficient in front of aluminum sulfate, the known, is 1. When the concentration of aluminum sulfate is multiplied by 2 over 1, you will see that the concentration of aluminum ions is twice that of aluminum sulfate. The same procedures may be used to determine the concentration of sulfate ions. The final concepts that we are reviewing today have to do with significant digits. All digits that are 1 through 9 are significant. It is only the zeros that we need to figure out. Anytime a 0 is in front of another number, it is not significant, but zeros that trail other numbers are significant. Logarithmic values, which we see when we perform calculations with pH, have a special rule. Only the digits after the decimal place are significant. When we add or subtract numbers, we should round to the lowest number of decimal places. When we multiply or divide, we should round to the fewest number of significant digits. Do not round off until the final step. As you can see in the first example here, the 12.3 has the lowest number of decimal places. Because we are adding, our final answer will have the same number of decimal places as the 12.3. In the second example, the 1.23 has the lowest number of significant digits. Because we are multiplying, our final answer will need to have the same number of significant digits as the 1.23. Hopefully you found the review brief and helpful. Please complete the September 6th quiz before attending class.